Hi, everyone. I just want to take a few minutes to talk about the terms that we usually use when we are talking about tables, frequency tables specifically, which are this kind of table here, where we've got a category and then how many things were in that category. And there's some other terms as well. So the terms we want to talk about are frequency, relative frequency, cumulative frequency, and cumulative relative frequency, which I know gets a bit long. So frequency is how many things are in that category. That's it. Frequency is the simplest thing here. Relative frequency is what percentage of the total things fall into this category. Cumulative frequency is how many things fall into this category or fewer, or lower on the table, which I'll show you in a second. And cumulative relative frequency, the same thing with the cumulative, like it's up to this point, but it's the percentage up to that point. So here I want to fill out this table using the data from problem 1B. So that was where Porter was very badly gathering data on statistics grades. So he talked to 36 students, 10 A's, 7 B's, 4 C's, 5 D's or F's, and 10 no answers, 10 declined to answer his question. So that's 10, 7, 4, 5, 10. Let's go ahead and put those in the frequency column. So that's 10, 7, 4, 5, and 10. 10 with a total of 36. And so here I'm considering no answer as a legitimate category. It's also fine to not consider that a category at all and just use use 10, 7, 4, and 5 as your category, but that's not what I'm doing here. I'm considering no answer as one categories. Relative frequency just means what percentage or fraction of the answers fall into this category. So the easiest way to do this is just this. 10 out of 36 of the responses fell into the category of A, right? And then same for the other ones. 7 out of 36. So you could put these into percentages if you wanted to. That's probably the way they're most commonly put in, but fractions are fine too. So total, of course, 36 out of 36, which is 1. Cumulative frequency is how much fall into this category or lower, I guess, or higher in the way I'm going to do it here. Basically, it means add up everything up to here. So starting here, there are 10 people with A's or better, and there are 17 people with B's or better, right? So that's the 7 people with B's plus the 10 with A's. And then there's 21 people with C's or better. That includes the C's, the B's, and the A's all added together. 26 here, and then 36 there. Right, so that's what cumulative means, is add up everything up to this point. Right, so if I'm looking down the table, I'm adding up everything up to this point, which there's only been one thing up to this point. So that's the cumulative frequency and the frequency are the same for the first category. For the second category, the cumulative frequency is the sum of the first 2 categories. And for the third category, it's the sum of the first 3, etc. That's all cumulative means, is add up everything up to this point. And so you can do the same exact thing with cumulative relative frequency, right? I'm just going to do 10 out of 36 here. And then this one's going to be 17 out of 36, etc. 21 out of 36, 26 out of 36, and 36 out of 36. That's it. That's all those terms mean. The ones we're going to be most interested in are frequency and relative frequency. Frequency, how many things are in the category. Relative frequency, the percentage of things in that category. That's really what you want to remember. These two are helpful when you have big tables where you want to talk about ranges of data, which is going to be significantly less common for us. It's really these guys that you want to concentrate on. So frequency, relative frequency mean number of things in the category, percentage of things in this category, or fraction of things in the category. Percentages and fractions I'll just use interchangeably. And then there's 2 other terms that I wanted to talk about. Correlation, or in correlation, which is response variable and explanatory variable. So this corresponds to X and Y in algebra. That's independent variable and dependent variable. So the response variable is the dependent variable. This is Y. It's the thing that appears on the vertical axis of your graphs. It is usually the thing that you are studying. The explanatory variable is the thing that we are thinking of as explaining the differences in the results in the response variable. So that's why it's called the explanatory, because it's doing the explaining. This corresponds to x, it's the independent variable. Just as an example we'll use a lot later in the course when we get to linear regression, is you might want to use how well somebody had done on their midterm exams to predict how well they would do on the final exam. Right, so those two things are correlated, right? The better someone does on the midterm exams, the better you would expect them to do on the final exams. And that turned out to be true if you use actual data, that those two things are correlated. But the explanatory variable there is the midterm exams, because those are what we are using to predict the outcome. And the response variable is the final exam scores, because those are what we're thinking of as the result. All right, I think that wraps up our discussion of terminology, so I'll go ahead and end the video there.